All right, well, let's go ahead and get started with our second day of class here. This is a little bit more of syllabus-related information. We didn't quite get to that on Monday. Now that we've had our first experience with the quiz structure, some of this will become a little bit more clear, I think, to you. There's a lot of acronyms there. These are the different components of this course. As the last thing I mentioned on Monday, there's a decent number of things we have to be on top of this semester. I'm going to try to keep it reasonably well organized so that you don't feel like at any given point in time you don't know what you are responsible for. First thing listed here is that reading assignment, the RAs, that is using that zyBooks platform. Each week we have a particular topic that we'd like to cover. In fact, really just this first week is kind of the mushy one because it's sort of introductory topic. So we're covering things, but nothing so concrete as of yet. As we get further on through the semester, there's these discrete technical topics that we are covering here. Each of those is going to have a zyBooks chapter associated with it. You're going to go to that link that is on Canvas, follow the instructions to make sure you do in fact have access, and complete the corresponding reading and sort of mini little questions that are part of that reading for that particular topic. It is not worth an absolute ton of total points. If you look at the total there's 11 of those topics, 10% of your score. It's really a worthwhile thing, though. It is a reasonably good textbook. I had this on the previous slide here, although I didn't want to belabor the point. There are lots and lots of different C references out there of varying quality. I threw a few of them that were openly available also on Canvas. But this resource, the Programming in C zyBooks, is a pretty decent one as well. If you go through each week and take the reading assignment seriously, you will learn, in addition to what hopefully we're learning here in class. And people learn in different styles, right? For some of you, just listening to my soothing, dulcimer voice each day will help you learn C. Others, reading is how you best learn, yet still others reviewing video, and others maybe just trying and, through trial and error. This is just one mechanism we have to help you become a better programmer. I will mention that with regards to those reading assignments, the topics in terms of how I present them are roughly comparable in terms of being this roughly kind of 1 week of material. The reading assignments are varying length to them. It's not always that obvious as you go to click into it how long it's going to necessarily take you to complete it. So my main suggestion for that is, as we do have the weekly schedule for which on these Wednesdays we will have these subsequent quizzes, it is corresponding to that week's reading assignment. And I just recommend you start relatively early and don't try to just like overnight it or last minute the reading assignment. So for example, we did have our micro quiz 1 today, but it was, as we saw, it was just kind of confirming that Canvas was working for our purposes and maybe learn a little bit about you. Now you can assume that for next Wednesday, that will be a quote unquote real quiz. It'll be based on the introductory topics. That is chapter 1 in that zyBook, reading assignment 1. I'd like you to start on it today. At least click on it, take a look at it, start to poke around on it. It is due the subsequent Wednesday. So when we look at not this Wednesday, but a week from today, by the start of class time, that is when that reading assignment is due. And the quiz for the next week's quiz on Wednesday is going to be based on that topic. So we're covering it in class. There's a reading assignment. There's a lab. There's also this coding practice, all associated now with this kind of introductory first topic. It's going to then culminate in a quick quiz, a micro quiz, and that's all then going to be then due for that Wednesday subsequent to when all these things are assigned. We got our experience with the first micro quiz. My goal is when we take those in Canvas, I expect everyone to get 100% on them. They are set up in Canvas for these micro quizzes such that you can take it multiple times. So you took it the first time and it said you got 1 out of the 5 questions wrong. Just go right back in and, it doesn't tell you exactly which one you got wrong, especially if it's multiple choice, but go back in and take another look and see what you might have gotten wrong and review it. So in that sense, they're testing what you have been really reading and learning through the previous week, but they're not necessarily a high stakes assessment, and that's not really their point. They're just kind of a little checkpoint for me, and as well as for you to determine, okay, here's what I feel like I should know, and I didn't get a couple of those questions right. If you take a micro quiz in 2 weeks and you had to retake it 13 times to get 100% on it, and it's only going to be 5 multiple choice questions, you'll still get full score for it, so it doesn't affect your grade. But that's kind of a hint that, okay, maybe I need to review this material again after the class is over. Maybe I should ask some more questions this upcoming week in class, because maybe I'm not quite as crystal clear on the material as I thought I was. That is, generally each week we're going to have these little micro quizzes, and then periodically I'd like to make sure that there's another little piece of individual assessment. I call those macro quizzes. So you can see in week 4, on the 13th of September, we'll have macro quiz. That is just a slightly longer quiz. You get kind of one crack at taking that quiz. It is also not meant to be a high stakes assessment. I did not want to call it a midterm examination, because it's really not in that sense. Still using Canvas, still multiple choice questions of a very similar fashion to what the micro quizzes will be having. I'll give you a little bit more time to work on it than the micro quizzes, which I expect to be just these 5-minute things. And the idea there is that it's a good checkpoint for me and for you as well. Okay, you've been coming to class every day, you've been going to lab. Let's see how much of that is kind of sunk in as we've gone. It's still pretty low stakes assessment, right? You can do the math there in terms of what those quizzes are counting for at the end of the day. In terms of the lion's share of where your grade is coming from in this course, that is those weekly labs. You will have your lab partner. The Tuesday group already hopefully got to meet their lab partner and have gotten started and gotten work done, and everything will be submitted with that partner working together. There's different strategies for that, and I've seen both strategies, multiple strategies, be perfectly successful with regards to how people structure their labs. Some say, well, there's 5 programs this week, so I'll take 3 and you take 2, and then next week we'll switch, or we'll do 2 and 2 and then we'll work together on the 5th. Other people say, well, let's just be shoulder to shoulder working on all 5. It's fine. Either one is fine with me. I only expect 1 submission per each lab team, and so my hope is that you have a functional group at the end of each week. The TA and I need to know if you're finding it not being functional. That doesn't necessarily mean we instantly fix the problem for you, but it's important for us to know that, and it happens. So if you find it happening to you, it's not necessarily that you've done something wrong. It just, statistically, it'll happen to a group or 2 potentially this semester. But you can see that's kind of the lion's share of where I'm expecting your kind of creative input to be this semester. We are learning, you are reading, we're doing these quizzes. It's all pretty low stakes stuff. The labs are also, in a sense, not low stakes, but I think you should submit each lab and basically know what your score is going to be on it. There shouldn't be surprises in terms of what you're being assessed. There's 5 programs. The spec is sometimes intentionally a little ambiguous in terms of what I want you to accomplish, but you'll generally know, yeah, programs 1, 3, 4, and 5, I got. Program 2 kind of half did it. Okay, I'll get a 90% on lab number 6, and that's fine. I do set all of these up, and I set up all assessments this semester that, there's 100% there in total, and I'm perfectly fine if you get a 100%. I'm perfectly fine if everybody gets a 100%. It never happens, but I'm perfectly happy if that is the case this semester. And if everyone gets an A in this class, I'm quite pleased with myself. I've done my job well. So there's all these different components, from the reading to the coding practice to the labs to the quizzes, and every single one that I assign, I do in the hope that every single person is able to manage that. And for that reason, there's really not need for curving or for special pleading for grades and things like that. You should know, if I've set up Canvas properly, at every day during the semester what your grade is in the class and what you maybe would need to do better if you want to kind of pick the grade up this semester. We'll talk more later on about the project. It is like a kind of student proposed lab that you kind of get to finish off this semester with your project team here. Make a couple notes on more of like the academic kind of integrity side of things. Collaborative discussion and just collaboration in general is just very highly encouraged. So I mentioned this on Monday. It is starting a little slow. I understand that, but it will ramp up. What I'm expecting of you will ramp up this semester. To succeed, you're going to need to be resourceful and ask questions. Ask them all of me, that's fine. Ask the TA, but ask each other as well. You're working with your lab partner on these labs, and that's of course another source of the person to bounce ideas off of. So definitely collaborate, discuss, and support each other. But keep in mind that ultimately your submissions are your own, right? So the quizzes are your own. You're not collaborating on the quizzes. And I don't think you'll need to, but please don't cheat on any of the quizzes. The labs and projects are in these teams of 2. We may have one team of 3 due to the odd number issue. I'm expecting both members of your lab team to be contributing on a week-to-week basis. I need to know if there's any free writers. Usually we can figure that out, but I do need to know if that's the case. I do a decent amount of automated lab submission checking. That is sometimes an issue in this course and certainly in follow-on courses to this one. Your work in the programs you submit does need to be your own. There's only so many ways to teach introduction to programming type topics. There's lots of ways. There's people who've taken this class or similar classes in the past. There are ways to go online and find certain partial submissions or complete submissions. You can just look at what other people are doing in the class this semester and potentially copy what they're doing. Take my word for it that that's something that, to the extent we'd like to be able to catch that, we can detect that. And the syllabus policy, which I don't bring up here, but is in Canvas, is pretty clear. You get in trouble for that. You get 0%. I get to be a not very nice person when that happens. It can be hard to resist that temptation. I will just say. I understand the temptation. You have limited bandwidth in a given semester, limited amount of time to work on things. You have a coding practice that's due in 30 minutes because it's due next Wednesday, coding practice 1. It seems unlikely you do it on coding practice 1, but let's just say you do. Coding practice 1, and it's due in 30 minutes next Wednesday. It's 11:30, and you say, well, all it's asking me to do is think of something and write some code for it. Instead, let me just Google an example and copy paste that into the Replit platform. We will catch that. And that's silly, right? We will catch it, you'll get a 0, you'll academic dishonesty, integrity unit, and all that stuff. Let's just not deal with that, right? Likewise for the labs. We got really stuck on lab number 4, part 3, and this other team got it working. Let's just ask for their code and maybe make a trivial change to it and just submit it as our own. It's not worth it. You'll get caught. Replit kind of tells us when those submissions happen from either online sources, from automated generators, or from other submissions either this semester or in prior semesters. And I don't enjoy dealing with that. So let's not do it, and you won't enjoy it either. I think that's sufficient. I don't think there's an issue in this class where you'll accidentally cheat in that way. It's not something that accidentally happens. When you get in quote unquote trouble for it, it's because it's kind of explicit and blatant that you were doing such a thing. And so it tends to not be a negotiation once it's detected. It's kind of an automated thing there. I want to add one more note about AI. Who here is familiar with ChatGPT? Just to give an example. Most of you, and that's fine. There are lots of large language models, the modern AI tools, and they've become pretty sophisticated at generating code given simple coding prompts. The example I give here is not in C, but it actually does a pretty good job in C as well. Here's my prompt I gave to it. Use Python to solve the n-queens problem. It doesn't matter what the n-queens problem, you'll know how to do it by the end of the semester, but use Python to solve the n-queens problem. Include comments that explain a programmer's thought process and also include unit tests. And it generated this for me, all the remainder of that code. Really nice solution. It's a textbook problem, so it doesn't surprise me it's able to generate a solution, but it generates a very nice solution for it. We talk about temptation to look at online sources. This is also a very tempting kind of thing. The Replit platform we use this semester has its own version of this as well to be able to take prompts and generate code for you. So first off, it's an incredible piece of technology. I won't deny that. It's kind of fun to play around with. From an educational perspective, we have to go back to what is the point of you being here? What is the point of all of us being here this semester, being here today? Well, the point of EE285 is to provide you with the means to develop your own skill set as a programmer, right? And to gain familiar with how to use computing systems and software in general, as we were talking about on Monday. This semester, typing lab prompts into ChatGPT or corresponding tools works pretty well. Get you a B plus in this class, I think. That's an estimate. I don't know. I haven't actually fully experimented out and tried that. When the prompts don't work, it fails very poorly, and you won't be provided code that you'll probably be able to debug yourselves. There's very good mechanisms also to detect the output of those tools as well. So that is not allowed. It's something that kind of every instructor at this and other universities teaching programming has to be concerned with. For me, I had to make the decision of what is my policy on AI tools, at least for this semester. Maybe in 5 years things will be different, because it is an interesting skill to determine how do I best work with these tools, how do I best create the right prompts to get useful results back out, how do I learn how to debug the output of those programs. Those are all interesting skill sets, but they are not the skill set that is the intention of this particular course. So it was my decision to make, and I did make the decision that that is not an allowable thing to do this semester to succeed in your programming assignments. I understand the temptation. So we will deal with that as it comes this semester. When you're given a lab prompt and you're stuck, what I would like you to do is ask a question of your peers, of your TA, on Discord, of me, come to office hours. I'm not expecting you, and you'll eventually not get credit if instead you take that prompt, if you take that lab requirement, that specification, and you just plug it into ChatGPT and take the result that gets generated from there. It'll get detected. It'll be very obvious even if there wasn't software to automatically detect it. Frankly, one of the reasons it's obvious is because that's a very well-written, mature, very proper solution. So maybe if you told it, do a mediocre job and generate the code. Maybe, pretend you are an introductory programmer and include a couple slight logic errors. That's one of the reasons it can be detected, but there's other aspects. Because this company that we use for the hosting of our development environment also provides its own service, it's very good at detecting when those services have been used. My point with all that isn't necessarily to scare you, right? My point with this course is to hopefully inspire you, whether it is fun or not, is in the eye of the beholder. I'm going to enjoy myself. I'd like you to enjoy yourself as you're learning. I'd like you to separate, the work that you have to do, which can always be a grind, right? You're a student, you're taking a lot of classes, you have the rest of your life to deal with as well. But from hopefully that you feel like you are growing and learning and kind of, making your way towards your next goal in life, either your kind of academic pathways or just your future career pathways. But that's my hope, that I'm not trying to scare you and say you're all going to have academic dishonesty issues and you're going to fail, but just to caution you about a couple of the pitfalls that have happened, historically in a course like this. If you're ever uncertain, if you think you're doing something on the edge of being an issue, just ask. And I'm always, I think I'm a reasonable person at the end of the day, so I'm always happy to help when you have those kind of questions. But that is my hope. My hope is to kind of, motivate you to learn more, to challenge you a little bit along the way, but really to leave you with the feeling of whether or not you enjoy programming and enjoy the course, but you feel like you're growing and becoming a better programmer. There was a lot just now. Any class, before we kind of move on from syllabus stuff altogether, I trust you to look at Canvas, read it yourself anyway. Any questions about course structure and what it's looking like this semester before we actually move into our real kind of introductory topics? Yeah, sure. Yeah, and I have to be a little careful when I use the term reading here with regards to that. It's a little interactive as well. So it will say to get credit for this, answer this little multiple choice question. So it's kind of active reading. A little bit of programming as well, but really self-contained programming examples for it. You will know what score you got on that as well. So Zybook will tell you have 95% of it done or 100% of it done for that assignment. You do not have to submit anything on Canvas for reading assignment 1. I have to write a script that goes in and checks the progress and then imports it into Canvas, and I'll do that after the deadline. Other questions? Thanks for the question. Sure. Yep. Yep. I mean, we're here today in 100 and something degree heat, and fairly modest air conditioning. So, yeah, we'll be here all semester on Wednesdays, and that does tend to be the case. That I get to see some faces only on Wednesdays. It is, again, it's a relatively small assessment along the way, but it's kind of also a chance to check in on people and make sure you're actually physically here, mentally here. But again, I expect 100% on those micro quizzes. I expect everyone to be able to get 100% on those micro quizzes. Other questions? Okay, so finally, let's talk programming. It's been a while. Well, so this is our quote unquote first program, and for historic reasons, it's extremely common when one writes a first program for what is for many of you, I believe, a new programming language. We write a hello world program here in that language, something whose goal is to print out some sort of hello message to the world. We take things a little differently here in W285. So instead of hello world, we will have a program that writes out, hello, my name is Inigo Montoya. You killed my father, prepare to die. If you don't get that reference, that's also perfectly fine, and it's not important for this course. But a slightly modified hello world message is all that we have here. Now, for better or worse with C programming, even for what's considered kind of the most introductory program one can write in the language, there's a lot of things going on here. So we're going to start slow with this and break it down, and eventually I think all the pieces will make perfect sense. It may not make sense today. Lab 1, all the things you're doing may not make perfect sense. A lot of kind of this initial programming you do, especially if you haven't had a lot of that experience before, is more kind of pattern matching than programming. I see this, and I need to change it to do this, and I'm going to kind of just match patterns and figure out what I'm doing. Eventually, though, the goal is that like you have an inherent intuitive understanding of what the program is doing. So let's break down the components of this code here. We'll go back to this slide in a second here. Here are the components of our C program structure, and from the simplest possible program we can create to more advanced, complicated things, they're all going to have some semblance of this same structure. That first line that was syntax highlighted in sort of light green is that pound include, if you hashtag include, no, pound include standard io.h. We are going to have some version of that in every program that we write. This is referred to as kind of a fancy term. This is a preprocessor macro. This particular type of macro, the pound include macro, is telling the compiler, we'll talk about what that is, the program that's interpreting our source code we're generating, that to literally take the contents of this other file that it's going to know how to find. The file itself, the name of the file is standardio.h. To take the entirety of the contents of that file and essentially copy paste it, insert it into the beginning of my file. So if I go back to this slide here, that's what that first line is doing. It's a way of abstracting away a lot of complexity. Standard IO refers to the variables, the functions, the interfaces that allows us to do input and output, basic input and output in our system. That file itself is actually pretty complicated. It's been written over a period of decades now. It supports all sorts of different systems and configuration. It's not meant to be especially readable by certainly introductory programmers, but even kind of more experienced programmers. It's in the order of thousands of lines of code, actually. So even our very basic hello world, while we're only writing a couple lines of code, we include that preprocessor macro that please copy paste that file in. It's actually thousands of lines of code already here. It's a way of abstracting away some of that complexity. Any code that we write that's going to want to print out something is going to require that we have that preprocessor macro there. So your muscle memory, trying to write some C program for coding practice 1, Replit generates that code for you anyway, but make sure I pound include standard io.h, copy paste that entire file in there. That's the first kind of magic incantation we have with regards to our C programs here. There will be other preprocessor macros. It is considered not a great feature of the language, but historic reasons it's there. In many languages, if they don't use something like that, they have to solve a similar problem of there's all this other code I want to use, but I want my program to be relatively simple. How do I abstract away all that other complexity? This is the C solution for that. Next, we have a declaration of a function called main. This is part of the specification of the language that you need to have a so-called entry point for your program. You need to have a place where I know my code is starting. Here's the first thing that's going to get executed when my program runs. In C, as part of the specification of the language, the default name for that function and the name of the function we will use all semester long, and in every C program you will likely ever write, it's going to be called main. Technically, it doesn't have to be called main, but it's for historic reasons and the vast overwhelming majority of the programs you will ever write, it will be called main. And that's literally saying, here's my entry point. I'm going to get started with execution. The code for the function for what's actually going to execute, that goes between those, you can call them curly braces, you can call them curly brackets, in between those two things there. And that's what's actually going to get executed. For now, int argc, char star argv, we're going to ignore that for now. There's some other optional features of how we can start our program. For historic reasons, we oftentimes have those there, but for now, actually, let's ignore those. The other aspect of main is with all the functions we'll eventually be writing, we need to return from that function. We need to say, okay, we're done with the function. Function's over now. Go back to where you were. We do actually need to care about the type of a function. This is something that, again, we start with this as our pattern matching. Every program kind of looks like this one, and you're in pretty good shape to start with. In this case, the particular type of function we've declared main to be is that it is an int function. It is a function that is meant to return an integer value, a whole number value here. So when we return from that function, in this case, we're returning back to the operating system itself, the runtime environment for which we've launched the program, we are specifying, I'm done with the function. In this case, that means I'm done with the program, and I'm returning a value of 0. And for now, that's sufficient. And in fact, for a large number of the programs we're going to write this semester, until we really feel motivated to write our own functions, but for a large number of the functions all semester long, for the programs all semester long, they will have this exact structure. A single function called main, returning 0. That gets you pretty far this semester. You can write a lot of really cool programs that are just a single function. We will eventually see the limits of that. They're more conceptual limits than implementation limits. We can get pretty far with just a single function called main in every one of our programs, returning 0 at the end of it. We can execute it. This is in Replit under like the lecture subcategory of Replit projects, and this is the same code that we have here. There are a lot of features of Replit, and I want to make sure I eventually get to all of them. There's too many features of it. I would argue not enough features here. I accidentally closed out of that. Let's try that again. So first off, one of the features, I did mention that the other day, which is I can actually see, instructors of the class can see who is programming right now, what you're working on, what things you have open. It's fine that some people are currently working on programs. That's fine. If you feel like you're being productive while we're in class, I'm all for it, so that's fine. I can see that. I'm not going to click on it right now in class in front of everybody, but I can click on it and see what you're currently working on. When you reach out to me on Discord, when you come to my office hours and say I'm stuck on lab 1 part 4, don't feel free to exit just because I see it open right now. I can just click on it and see where you're at and type a little hint, provide a little help. If you're missing a single semicolon, let's not lose sleep over it. I'll add the semicolon for you and you can move on with life, right? Sometimes the bugs that like are an hour bug for you are really just a couple seconds. You just got to find the right second to kind of fix it. In terms of the features of what it provides, there's a lot going on here. And as I was about to mention, there's maybe too many features. This is a relatively young company that is really trying to grow and acquire customers. And for better or for worse, the interface keeps changing every few weeks to some small extent. They keep adding new features that we don't necessarily need in this particular course. But the basic structure is going to look like this all semester long, where generally you're going to have a split pane kind of view of your system. And in one of those panes, you're going to have the source code that you're currently working on. It will not always be called file main.c, but that's by default, and it's going to work pretty well for us until we understand why we may not always want that to be the case. That'll be the source code. This is where you're typing and making your changes. In this next window here, we have the runtime environment in which we are effectively remotely connecting through our web browser to cloud servers, probably hosted somewhere in California right now. We could probably look it up based on some IP address information, and providing us a remote access to a Linux terminal running in a cloud computing environment. It's pretty cool. It abstracts some of the implementation details away. I call this the magic run button. It is not a magic button. We will talk about how that button actually works, and we will understand the steps of those buttons, but that's what allows us to run our programs. So we have our source code, and that button is actually doing a number of things, executing the code here. We will eventually become real experts in printf, stands for print formatting. It is our main fundamental output function here. It is critical for us to be able to print things out. There are lots of ways we can debug our programs, but one method that we're going to use quite a bit this semester is to take the state of our program at any given time and use printf calls to print out the value of something to help us understand what our program is doing. There's maybe some purists who say, you know, well, there's more formal methods we should be using to debug our programs. This gets us very far. We will learn a ton using print methods to debug our programs here. In terms of what that button is doing, here's a slightly more formal view of it, of how the program development process is working. This is not unique to Replit, but Replit is one implementation that we are using this semester. We start with kind of the source code editing stage. That is using some sort of word processor, is kind of a data term, some sort of text editor, some way file edit software that we are using to make changes to the program that we are interested in. That was that leftmost pane in our Replit environment. When we'd like to then determine, okay, what does our code do? Are we done? Did it work? There's then a series of programs we actually call to determine that for us. The first of those programs referred to as a compiler. Compiler compiles things. It combines things together. From our perspective, an appropriate definition of a compiler is a program, a piece of software that takes text specifying our program in C and generates ultimately the binary blob, the ones and zeros that are running on the underlying machine. We are compiling our program. There's a couple stages associated with that process that we will eventually learn a decent amount about, but today I don't want you to stress out too much about it. There's compiling the file that we have specified. That's that second circle on this slide here. We are then oftentimes needing to take what we have written, the little binary blob that we have generated, which is an object file, it's a bunch of ones and zeros. We can take a look at it if we want to. We'll link it with other binary blobs that either other people have written, developed, or we ourselves are currently developing, and link those together. Take my main.c and the corresponding binary blob, take the standard IO library binary blob, combine them together into one larger binary blob. That doesn't sound very scientific, but that's ultimately really what it is. Ones and zeros corresponding to actual data and instructions, the binary that the underlying processor, the CPU, can understand for our particular system. And then finally, although it's kind of separate from the actual development process, we actually then need to take that executable, my exe file, my application that we ourselves have just compiled, and now we need to execute it. We need to actually run it. Think of that as a loader. We can sometimes just think of it as a runtime environment. And we actually then execute and actually run that program. That magic quote unquote run button does all of those things for us. It compiles, it links, and then it actually executes the program. There'll be lots of bugs along the way. We already talked about that a little bit here. 3 major types of errors. First one is syntax errors. Syntax are, again, the rules of the programming language. If I have a function, it has to use curly braces. It would be cool if it didn't have to. Could have been if we could do square brackets instead. Well, you can't. That's a syntax rule. Replit, the development environment, the text editor, that's, IDE is the other term used, is pretty good at letting you know that you may in fact have a syntax error with something that you've written. You eventually, there's a little bit of a chicken and egg issue because you eventually need to have a deeper understanding to appreciate the kind of warnings and errors that you do get. So once you already know what you're doing, then the warnings and errors are really useful for better or for worse. But when you see red squiggly lines, it's bad news. So you should know and assume that, well, my magic run button's not going to work. Now, that's pretty brutal though, right? I mean, and C is notorious for that in the compilers we use, that a small error that's syntactical can lead to a lot of error messages because we've confused the compiler quite a bit here. Other times it's not so awful. Very common mistake for those who come from other programming environments and languages, missing a semicolon. Now, I don't know how well you can actually see that, and even looking at it on my screen, I really can't see it all that well. The IDE is warning me that I missed a semicolon, but it's kind of subtle, right? You have to kind of, like a misspelled word in Microsoft Word, and there, it is actually running a piece of software that's checking your source code at all times here. It's a little formal, but it's correct. The compiler's never quite wrong in that sense, or very, very uncommonly is the compiler itself wrong. Expected a semicolon after expression. Well, that's correct, right? Yeah, it's expected it. Doesn't mean it needed to be there. When I then actually try to compile it, it gives me a very similar looking compile error. And it is helpful. Again, you have to really know where to look. When you see red, something is wrong. In some sense, that's a good thing. Okay, I have a bug. It's telling me I have a bug. At least I know I have a bug. I've learned something. I know where to go next. The file that the bug is in, that the compiler thinks the bug is in at least, it doesn't always get this exactly right. It's in file main.c. Well, good thing, that's the only file we have. It's on line number 8, okay? And column, which is of some value, right? You can tell what column you're on. It'll tell you what column you're on. Column 29 is where it expected a semicolon. And it does kind of tell you, hey, expected a semicolon literally right there with something of a suggestion for how to fix it. Not all of those are going to provide useful compiler errors. It's there though. Missing terminating double quote character. Okay, it's missing a terminating. Again, very formal kind of English it's going to use to tell you what sort of bugs it sees, but it is going to tell you what bugs it sees, at least for syntax errors. When you have no squiggly lines, you very likely don't have any syntax errors. Having a program that doesn't have syntax errors certainly doesn't mean it's working. That's just the first category of error. You got to get past it. You can't run and test your code until you've fixed all your syntax errors, but then next you have your runtime errors and or logical errors. Code compiles, crashes for some reason while running. C makes it relatively straightforward to write a program that will crash on you. Replit tries to hide some of those details away, just in the spirit of user friendliness and in the spirit of education and trying to make things not as harsh as the real world could be. We will have lots of runtime errors this semester. Hopefully not so many until about halfway through the semester, because we're not messing around with too many of the things that should cause runtime errors until about that point in the semester. But C as a programming language is relatively close to the underlying hardware in terms of the abstractions it does provide for you as a programmer. That allows you to really mess with things in kind of a fun way. And then, of course, we're going to have lots and lots of logical errors where the code compiles, doesn't crash, it just doesn't do what you hope that it's going to do. It's wrong. Replit won't be able to fix that for you. Won't be able to say, oh, your code is wrong. If you considered multiplying by 7 versus multiplying by 6 on this line of code, it's not going to have that kind of intuition for what to do. This is where you as the engineer come in. You fix the syntax, it doesn't crash. Now I can actually get it to generate the right result for me at the end of the day. The other consideration that is not unique to C, but there's only a few programming languages where this is a primary consideration, is that C actually has effectively no rules regarding the white space in the document, in the .c file that you are editing, your main.c file. No rules regarding how many spaces, how many blank lines you need, what kind of tabs, or if you even have any tabs at all inside the document. The first thing the compiler does when it goes to compile your file to determine what it should be corresponding to is it gets rid of all that anyway. It strips all that out for it. So in theory, you can make your C code look, however you want. We, as people learning how to program, should really err on the side of readability and consistency, right? You have an audience for the code that you're writing. There's two important people who are the audience for your code. There's me. I have to grade it. TA, I guess, right? So I have to be able to understand what's happening. I'm the audience for your code. So write code that I can understand in general. The other audience is a little bit more subtle. It's you. It's not you today necessarily. As you're writing it today, you know what you're doing. It's you tomorrow. It's you a week from now. It's you a month from now or a year from now. Write code that you yourself will understand when you look at it at some unknown future point. C, as a programming spec, does not require that be the case. And that leads to all sorts of trade-offs that are totally valid, right? I have this as 4 different calls to printf to print those 4 lines here. There's no requirement that that be the case. I mean, you can do, let's make sure I do it correctly, you can combine 2 of those printf lines together. This is the new line character, it prints the new line itself. That's totally valid. And I don't think there's any argument that what we just changed is more or less readable than what we previously had. So we can absolutely do that. That's perfectly valid code to do that. It also doesn't require that we have any comments whatsoever. We can put it all entirely on a single line if we want to do so. This is valid C as well. Now we're getting a little bit borderline in terms of readability. We have a consistent tabbing here, but there's no requirement that we do that. We can put this up here. We can add 40 lines here. That's all perfectly valid here. But again, what's the point? Who are you trying to confuse with the code that you're writing? One thing that this replit environment does provide, looks like it's a little hidden here, is there's an auto formatter. So if you're uncertain about how well you formatted the code, oftentimes when I look at your code, I'm just going to hit that button first off because I need to be able to see it. So you don't have to worry about hitting tab the right number of times or space or making sure it'll do it for you. It's pretty decent for that. C allows for all sorts of code that is in fact not especially readable. What does this program do? Well, who knows? It's intentionally meant to be very difficult to understand. It's a competition that's been going on for several decades now that I enjoy, the International Obfuscated C Coding Competition, where the goal of the competition is to write as logically impenetrable C code as possible that still does something kind of interesting and fun. There's an example for this in lab number 1. There's just a separate example here in the lecture code that I provided for this week. You're not supposed to be able to read this and have any idea what it's doing. If you find that your programs look more like this than they look like the hello world nicely formatted example, it's always important to take a step back and say, okay, why does my code look obfuscated? What does this particular code do? I don't know. Generates, the tabbing is a little odd, generates a little smiley face sticking its tongue out at you here. But again, with regards to the debugging process, your code this semester is going to be imperfect, and you're going to be spending a lot of quality time finding and fixing bugs. I'll provide you with some techniques. We'll be learning some techniques to help us do our debugging. None of those techniques take the place of just kind of critical thinking. Okay, my code's wrong. Syntax error, look to hints. Runtime error, let's discuss. That's a good time to raise a question. Logical error, okay, it's wrong. Why is it wrong? What kind of things can I inspect in my program, either visually just looking at it or adding more print statements to review output that can give me some insight as to why things are wrong? We are not writing hundreds of lines of code each week this semester. It's closer to tens to dozens at most. Small, self-contained programs that still are going to have bugs in them. And what we're really developing is that critical thinking as part of the engineering problem-solving process of, it's broken, why, how do I fix it? It'll take time to develop that. Some of it's innate, some of it's just something you develop over time here. Critical thinking is an important part of that. When it's broken, ask why. Keep asking questions until you can get yourself to an answer. And our last thing here today, I always like to show a picture if you haven't seen it before. The first computer bug circa 1945. You can't read the handwriting. A moth flew into a relay, and this is Grace Hopper's notes on when she discovered the actual moth, and that's why the system was not working as it was intended. Go out in front of Coover and see the statue of the moth that we have out there, and that is a small homage to her finding the first quote-unquote computer bug. You will find many, many more this semester. Probably not as fun as an actual physical bug that fried a relay, but who knows, maybe we will. Let's leave things here for today. Good luck for the Thursday lab, folks, and I'll see everyone on Friday.